Welcome to Wilson Manifolds. We're showing our new C8 Corvette manifold that also fits the LT1 and LT2 engine. We designed it to fit a stock Corvette, all the stock sensors, throttle body, everything plugs in as an OE piece. We're going to take you and show you how we started to design it and manufacture it. And then we're going to show you how it performs on the chassis dyno. Here's a C8 Corvette that we're going to test the manifold on and run some chassis dyno and back-to-back tests from the OE plastic manifold to our manifold. This is the first step on our design process. This is Rob Mansfield. He's been with us a long time. We mock up everything on a block and start looking at all the data we need to look at to make it sure we approach the chamber correct.
As Keith was saying, we take the original block, the cylinder heads, we look at all the dimensions, we take certain dimensions into factor, we look at all the approach angles, the sidewall angles, and how it enters into the bowl of the cylinder head, and we go from there to design our billet manifold.
And then Robbie will draw that in 2D with all our calculations, and then we go to CAD and draw it in CAD and still go over the numbers one more time. Okay, now we're in the engineering office. We're at Robbie's desk. He's showing a 2D drawing he did that we then go into CAD and then make our part.
So literally we take all the dimensions that we took from the block and the head, and then we'll go ahead and apply those in a 2D drawing. We'll create a manifold that we're gonna build out of billet. So we'll look at all the sizes, dimensioning, the approach into the cylinder head as it would in a 2D drawing, and then they'll transfer that into a 3D drawing when they go ahead and do the process.
On this side of the engineering office, we have Nick. He takes a 2D drawing. He'll start drawing it in CAD. We're fortunate to have the file from SEMA Garage. So we have the actual C8 model of the complete engine bay. So now when we draw our manifold, we can make all the stock components fit. The air cleaner, the inlet tube, all the sensors, everything plugs into the stock manifold when we draw ours.
So right now we have the stock manifold, everything just as it came from GM's CAD files. And this is where we start with our design work here. So then we can switch over to the C8 manifold and everything bolts right up. So once Robbie and Keith have gone over all of the requirements for any manifold, then they'll come over and sit with me, and we'll start with the GM CAD and start drawing in all of the individual runners to make sure everything lines up exactly with the original manifold. So next we'll start optimizing both the runners and the plenum design around the performance characteristics we're looking for. At the same time, we have to optimize for all of the existing sensors and packaging limitations such as hood height, throttle body placement, and clearing all of the fuel injectors and everything else. After countless revisions, we finally arrive at a finished product, and even included fuel injection, nitrous bungs, and fuel rail stanchions for added fuel. The last step of the process is design for manufacturability to ensure we can actually cut the part that we've designed. Here you can see our toolpath simulation running to ensure there will be no collisions and everything will cut smoothly once we actually get it on the machine. And once everything checks out, we send it off to the machine.
Before we go out to the CNC and the machine shop, Chris here is working on a 255 throttle body that GM chose for their 1,000 horsepower crate engine. And they chose it because it flows so much air. He's doing an update for GM right now.
So here we're just working on finalizing a toolpath for the idle air control. As you can see, that's the top, and then over here we have the bottom of it. Pretty much after this, these toolpaths are all good. It's pretty much go out to the Haas and run this and see that it mates up with our throttle body with all its new revisions.
This is our Kuma MU8000V. It's a 5-axis machine, which means we're able to move in all 5 of these axes, which lets us cut much more complicated parts.
Our Kuma 5-axis machine, they run a selection of elbows we make. I forget how many part numbers elbows we have, but we have quite a few of them. We have some with center dividers, that lines up to the throttle body at wide open, splits the plenum. We have two-piece throttle bodies. We have a real low one for certain people who have hood height issues. So we have a whole line of products that come off the Kuma. We're at our flow bench. We have drawn this in CAD. We actually grew a prototype runner before and flow tested. We're confirming what came off the CNC now is accurate to what we had in CAD and what we grew as a rapid prototype. Previously, we flowed the C8 manifold, the stock one. So we have all our numbers. So now Noah's gonna flow test this.
This is our Superflow 1020. We have this set up at 28 inches and at 650 lift. So now we're gonna go ahead and start a test. We picked up 50 CFM over the stock plastic manifold and 500 swirl as well.
That shows that our previous CAD drawing and all that is correct. Like I said, we did grow a prototype. We knew it was good before we came here, but we're just verifying it before we go putting it on the car. We're making some dyno pulls today on the final product and seeing how much power we can find.
I think we still have a little bit more to go, so we're going to keep pushing and see if we can find some more power.
Sean does all of our final assembly for throttle bodies, our elbows, our nitrous systems, and now the C8 manifold that we're building. He does the final inspection and looks over everything and then builds it.
So I just make sure that everything goes together nicely, make sure everything's torqued to spec on everything. You know, depending on the application, we apply Loctite torque wrench for torque specs, make sure the O-rings are seated, make sure everything's torqued down, and we'll mock it up on the engine block just for final assembly to make sure its fitment is 100% perfect.
Here's the finished product. We haven't final assembled it. You can take the lid off. Everything's O-ring and dowel pinned. You can see the extent of runner length we went to in a plenum design. It helps with distribution. We always want the best distribution possible, but this is much harder to design, cut, and 5-axis cut, but we needed runner length. Most manifolds, the OE manifold was very well designed. You know, it makes power across a very broad RPM range. Well, we wanted to enhance that and not give up anything. So we ended up making power all the way through. We didn't give up anywhere. And in the design too, we also added an extra fuel bunk so you can add another fuel rail and a nitrous bung, and it's in the CNC program so you can order with or without. The other thing that we did, it's never been done before I know of, is we made a heat shield. This is a special material that does not transfer heat, and it's above the aluminum. The aluminum captures it, the O-ring is still there, so the only thing touching the cylinder head is the O-ring and this material, and it keeps heat from transferring from the head up into the manifold. You still can heat the manifold up with engine bay heat, but since you have ambient air going in the engine, the manifold doesn't get near as hot as it would, you know, usually as aluminum. And that's always the biggest complaint on aluminum manifolds, taking plastic off, is people say they heat soak. So we addressed that as well. Mike is just gotten through running the C8 with our new manifold, and we found quite a bit of power, more than we even thought we would. So this part ends up being very successful. We're very happy. We picked up more than we thought, and we didn't give up anywhere. We have a little, we're still working on the middle area. It doesn't fall below, but we picked up down low, even running a different runner length, and we held up top. And you can see where the OE manifold starts falling off very quickly. Ours keeps pulling. So in a case where people work on it and run a different ECU and track at the track or something and run more RPM, we will even gain more power. We're very impressed that we picked up power throughout the thing, and quite a bit of power. We went from 413 to 441 on horsepower, and from torque 395 to 407. So to pick up all the way across, except in this small area, it is very good. Usually in a manifold change, you give up bottom and gain top, or give up top and gain bottom. But we worked at the design very hard to try to pick up all the way through. Finished our first session of dyno testing, just changing the manifold and calibrating the engine. We're up 28 horsepower and up 12 foot-pounds of torque. We're still got quite a bit of testing to do to understand more, but Mike will fill you in on the rest.
So guys, we had a 7 horsepower spread on the stock manifold, stock tune on this vehicle after doing some back-to-back runs. We bolted our piece on and we ended up gaining about 5 to 10 horsepower. Our spread actually also went down as well. We went from a 7 horsepower spread down to a 5 horsepower spread. With the tune and everything done, we ended up with a grand total of about 23 to 28 wheel horsepower gain. And we gained some torque behind that as well. So all the results have been really good. I've been really happy, and hopefully we'll be able to keep on pushing and find a little bit more. So our bolt-on piece picked up so much airflow, we picked up a grand total of 10 pounds of air. We had to go into the tune and adjust that a little bit more to dial it in. This manifold flows so well that we actually had to adjust the fueling strategy a little bit. So given the airflow gains that we've seen, we still are running a stock air box, stock air filter, stock throttle body. This is an absolutely massive gain for just a bolt-on piece. And not to mention, we're in South Florida. It's 95 degrees out. We probably have about 85% humidity. It's some tough weather out here.
All right, we finally dynoed our project we've been working on for a few months for the C8. It took this whole team of people to input from all of them to build this piece. And if you want a new manifold for your Corvette, give us a call.